lot to do today also. All right. And again, remember the importance of doing the work. All right. Making sure, all right, you are working with me, because again, it should be easy if you just do it every day. All right. It's hard to remember everything there is to know about the in-center, the circumcenter, the ortho center, the centroid. All right. If you're not keeping up with me. All right. So today I'm asking, there was some typos. I don't even remember where the typos were. So I feel like number 7 and 8, there's no B. Oh yeah, there is. Was 7 and 8 okay? Where was the typo, guys? Tell me. Which one, Simon?
7, 8, 9, and 10. The wiggly triangles wrong.
On the next worksheet? Oh yeah, here we go. PQR, thank you. So yeah, but okay, so that doesn't really matter. They didn't mean, all right. So this we could have just fixed, right? They really just meant triangle. Yeah, I can do them. Here we go, but I'm just going to erase this. I want everybody to do that too. That should have been YGL, it looks like, right? So let's fix that. All right. And if it's the in-center, I want someone to tell me, what is the in-center? How do we get the in-center? From the what? You guys, you have to be able to tell me that now. The in-center is the what? Say it again. Yes, that's the key word. I want everybody to make sure. Angle bisectors. Please write that down if you didn't know that. When I say the in-center and you can't say it's from the angle bisectors, then you can't answer the questions. That's what the problem is. I tell kids every single year, if you don't understand what in-center, ortho center, median, circumcenter, then you can't answer the questions. If you know that, then the questions are easy. All right? So the in-center is the angle bisector, but I also want you to know the in-center then is equidistant to the sides of the triangle. Equidistant to the sides of the triangle. That's what that's saying. All right. Now I tried to show you yesterday. Watch this, guys. If I were to extend this out here, and I extend this out here, and I'm extending this out here, all right? Is this what they're talking about? Are all those the same? No, that is not what they're talking about. That's why this one's hard. All right, that's not what they're talking about. That distance is not the same. I'm trying to show you this yesterday and I didn't do a good job, so I'm going to say it again. Perpendicular, the one that is perpendicular to the side is the same. Now again, sometimes it looks like that is the perpendicular and sometimes it does not, right? Hopefully you understand what I'm saying on that, all right? Now the blue lines would all be equal. That's how I know it's not a very good picture, all right? And again, the in-center would allow you to blow up a circle and it would fit perfectly on that triangle, all right? That's what that means, all right? But obviously that's not a very good job. I don't think the publisher, whoever created this worksheet, actually did this. I think they just drew a triangle and just put things in there, all right? So again, with that information, if circumcenter, so let's talk about the circumcenter. What is the circumcenter again? The perpendicular bisectors. Perpendicular bisectors. Do the perpendicular bisectors have to go through the vertices? No, all right. do not have to go through the vertices. They do not have to go through the vertices. Notice down here, when you draw the angle bisectors, does that have to go through the vertices? And the answer is what? Yes. How can you bisect an angle without going through the angle, right? And again, these are the types of things it's okay to make a mistake on, but I always try to tell you, if you think logically about it, it makes kind of good sense. All right? So again, the circumcenter, right, means that it's equidistant from what? Equidistant from the vertices. Whereas the incenter is equidistant from the side of the triangle. All right? Now again, I'm telling you, it's on the test, people just jumble these all up, and they're, I mean, to me, they're easy points in my opinion, because you guys all have good memories, right? But you can easily mess them up. All right, that's what I'm saying. Make sure you're writing some things down. What, Sam?
What is equidistant?
So this right here would be equidistant from the vertices.
Okay.
This point, which is called the circumcenter, is equidistant from the vertices. That's what that means. You with me?
Mm-hmm.
All right. So if you are at a triangle and you wanted to say, what point is equidistant from these points right here, you would draw the perpendicular bisectors, and it would find the point that's equidistant from the vertices. If you want to know where in the triangle is a point equidistant from all three sides of the triangle, you would say, draw the incenter, which is just the three angle bisectors. All right. Now, I think that's it. All right. Does anybody have any questions now on these two worksheets? Go. What?
Number 11.
The sculpture?
Yeah.
All right. It says a triangular entranceway has halls with corner angles 50, 70, and 60. The designer wants to lace a tall bronze sculpture on the round pedestal in a central location equidistant from the three walls. That's exactly what we're talking about. How can you find where you should put the sculpture? Easy. Find the incenter. That's exactly correct. All right. So if you're having some type of triangular room, right, and you wanted equidistance from the three walls, that would be the incenter. All right. Incenter. That's exactly correct. Yes. All right. So here we go. So hopefully I kind of summarized yesterday, because I think that was a lot of information. All right. A lot of information yesterday. So now I have somebody who's asking me about question number 12. All right. Yeah. I think someone asked me about this. This doesn't make any sense. Right. So yeah, this doesn't make sense to say that's not even drawn, right? I have no idea what that is. All right. I think it should have been QPA, if I'm not mistaken. That's what I would say. All right. Wait a minute. Yeah, no, I just don't think. Right. I'm not sure if I draw that here. Yeah, I don't. Yeah, that doesn't, to me, that doesn't make sense. All right. So again, don't worry about number 12. All right. Homeschool peeps, are you guys okay with everything on this? All right. The summary was super important what we just did. All right. Everybody should be able to say, when I say incenter, when I say circumcenter, you got to be able to say circumcenters, perpendicular bisectors, incenters, angle bisectors. All right. I think the math is super easy. It's just the words. All right. So now what we're going to do is we're going to flip over to 5.2. So everybody pull that up. And these are the problems I liked. 1, 2, 5 through 12, 14 through 25, 34, and 35. All right, so we have two new definitions today. We have centroid and we have ortho center. Centroid and ortho center. All right, so I have to show you lots, all right, about the centroid. The centroid is kind of cool, actually. So here we go. These are the types of things that I would like you to know. All right, so the median of a triangle is drawn from the vertex to the midpoint of the opposite side. That's what a median is. All right, it's not the angle bisector, right? This is equal to this. All right, so you bisect AB, and then you draw from C to D. What?
So is that like the line when we were doing the proofs where you didn't study reflective property on the triangle?
No, I don't want you to think of it like that. All right, I just want you to say, look, a median is if you take, like I'm going to draw the midpoint of AC. That to me is about the midpoint of AC. So then what I'm doing is I'm going to draw from here to here. Okay? Well, first of all, these angles aren't equal. You with me? So the median is not the angle bisector. All right, it kind of looks like it sometimes, but it doesn't have to be. And depending upon the triangle, it could be, right? But if you have just a scaling triangle, the median is not the angle bisector. All right, so now over here, if I draw it here, all right, if I draw it right through there, then we say this are equal, and then these three are equal. All right, so again, I can't say anything about the angles. The only thing I know for sure is that if I'm drawing the centroid is the point of concurrency. That's the point of concurrency. All right. So I found the midpoint of all three sides and drew the line from the vertex to the midpoint. That creates a median. All three medians intersect at a point of concurrency, and that point of concurrency is called the centroid. All right? And there's some few cool properties about the centroid. All right? How many triangles were created from drawing the centroid? 6. And something that's really cool, all right, is that the centroid divides the triangle into 6 triangles that have equal areas. 6 triangles that have equal areas. So all 6 of these areas here, if you were to calculate the area, they would all be what? They would all be exactly the same. So that's just some good information. All right. Now, the other thing that's interesting about the centroid is that the median is divided into parts. All right. What I like to call, and I'm going to erase this right here, and all this other information so I can explain it to you. It's easier. What I like to do is I like to say, I like to say this from the centroid to the side is X, and from the centroid to the vertex is always 2X, which means that the median itself is what? The median itself is what? 3X. All right, so there's a ratio that it's always divided up into. All right, now they do 2/3, stuff like that. I just don't like that. All right, you can look at that and read what they say, but to me, it's much easier, in my opinion, to think of it as, and again, if you really can't ever forget it, because if you draw it out, this length right here is always smaller than this length right here, so it's easy to remember. All right, the shorter side is always half the longer side, or the longest side is always what? twice as much as the shorter side. All right, which then calculates, then the whole thing would be 3x. All right, that's very simple, very simple. Make sure you know that. What?
Can it,
No. There is nothing. You're right. That's kind of a good question. All right. That's the unique characteristics of the centroid. That's all I got. What?
can
Well, because I'm showing you the relationship. Let's say this was E. All right. And let's say this was F. EF and FA, there's a relationship. AF is always twice EF. That's all I'm saying. Always. All right. Harris, did you have something, buddy? I'm sorry.
can they not be isosceles triangles
Oh.
or?
No, there's interesting characteristics about isosceles and also if I did equilateral. All right. If we drew an equilateral, they would all be the same. All right, which is interesting. Maybe I can show you that. But again, I don't like doing equilateral or isosceles because it can lead to some false assumptions. All right, that's why you should always do scaling. All right, is everybody okay with that? All right, so again, you can remember this right here, but I don't like to do it that way. I always tell kids, in my opinion, it's easier to think of it as x, 2x, and 3x. So the median is 3x, and it's divided into a short part and a longer part, which is x and 2x. All right, now the next one that we're going to talk about is called the Ortho Center. And the Ortho Center is found by drawing or constructing the heights. All right, now a height is just simply, when we say measure the area, it's always 1/2 base times height. So the height is simply the perpendicular distance from the vertex to the opposite side. So this right here is obviously called the height because from B, that's perpendicular. All right, now if you have an obtuse triangle, believe it or not, the height can be located where? On the outside of the triangle. All right, the altitude can be on the outside or the height can be on the outside. All right. Now, to me, the Ortho Center is the boring one, all right, because it doesn't really give anything special here, all right? There is just the point of concurrency is called the Ortho Center, and I found out that ortho has a root that actually means perpendicular. That's why they call it that, all right? Ortho means perpendicular in some other language, all right? So, so that's how we got Ortho Center, all right? Now, again, I wish I could say, wow, the Ortho Center is pretty cool, but to me, I've tried to look up some information on the Ortho Center, and I just don't really find anything interesting. However, I will say something that's interesting is this guy who figured all this stuff out was named Euler. And there's a famous letter on your calculator. It's called E, all right, which eventually in Algebra 2 you will learn is 2.718, blah, 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 just like pi. He was a really good mathematician and he figured all this stuff out, all right? Now, there's called the Eulers Line, all right? So if you were to do, believe it or not, if you take a triangle and you construct the ortho center, the end center, the circumcenter, and the centroid, what's fascinating is all 4 of those points of concurrency are always on one line. All right, they're always on one line. All right, so that's just some interesting, I'm not gonna ask you about that. But again, I just think that's really weird. All right, how all 4 points of concurrency are always on one single line, all right? And again, I was going to demonstrate that, but that takes a lot of time, all right? That takes a lot of time. So again, Ortho Center, not much going on there, all right? I like the in-center and the circumcenter because you can draw circles. The centroid, all right, is simply the medians, and the ortho center is the altitudes. All right, now let's go ahead and get started. All right, with today. All right, so here we go. Let's take a look now at 1 and 2. So P is the centroid. So automatically, as soon as P is the centroid, here's what we know. This is equal to this. These two are equal. These three are equal. This is X, and this is 2X. Now I'm going to draw this. I'm going to say this also because I want to make sure you're understanding me. This is Y, and this would be what? 2Y. This over here would be Z, and this is what? They do not have, they are not equal, of course, unless they're an equilateral triangle, all right? But we're not talking about that. Does everybody see that now? All right, that's how you break it down. That's all there is to it, all right? So now, if PF, so PF is 6. So what's PC? 12. Good job. It's either 3 or 12. And I always tell kids, just look at the picture. You can always tell from the centroid to the vertex, it's always bigger than from the centroid to the side. So now if AD is 15, if AD is 15, what is AP? Exactly. All right, so how do you do that? To me, it's just divide by 3. And that gives you the shorter side. And then you double it, and that gives you the larger side. Come on, guys, this is super easy. All right, just rules. All right, stay with me. All right, now number 3. It says an interior designer is creating a custom coffee table for a client. The top of the table is a glass triangle that needs to balance. Oh, I forgot to say this. So believe it or not, this is another really cool feature. The centroid, right, is called the center of mass. All right, so if you were to take a triangle and cut it out and point to the centroid, if you could figure out what the centroid is, you could balance it. All right, so the centroid is also called the center of mass. That's why that triangle, if you put this leg, whatever you want to call it, on the centroid, the triangle would stand perfect. All right, it would be able to sit on that piece. All right. So now, here's the interesting part. All right, so now it's going to give us this information, and you have to find the centroid. All right, so that's what we're going to try to do right now. All right, I'm going to show you how to find the centroid. And then I'm going to show you how an easy way to find the centroid, and then you're going to be mad at me because I should have just showed you the easy way first. But of course, we don't want to do that. All right, so what I want everybody to do is to, I'm going to grab these points right here, and we're going to put them on it. I want everybody to create another page. Add a page, and then we're going to go ahead and add paper. We're going to do graph paper. All right, and then what I'm going to do is I'm going to grab these points right here. Oh. All right, so here we go. What are you guys asking? All right, so now we're going to find the centroid. All right, so here we go. All right, so what we want to do now is, does everybody agree I just need the positive side of the, I just need quadrant 1. Is everybody with me? So I'm going to try to draw an X and Y axis here. All right, let's see what we got. What? Yeah, it lets everybody add a page. It's not personal. All right, here we go. 3, 6. and then 5, 2, and then 7, 10. All right, so here we go. Let's draw this. All right, guys, come on now. Everybody get it up and running. All right, this is going to take a second. How do I what? Come on. You have the 3 dots at the top, then you click over and it tells you about the paper. All right, and then you hit paper and then you convert it over, and you want the small graph paper. All right. Now, if you haven't added a paper, it won't, you know, it has to be on a blank paper. It can't be on the worksheet. All right. So now, here we go, guys. All right, let's do this now. All right. Yeah, now, look, again, this point right here is 3, 6. This point over here is 5, 2. And this point over here is 7, 10. All right, now there's a lot of work involved here, so just stay with me and pay attention. All right. So I want the centroid. In order to find the centroid, I have to do the midpoint. All right. So let's just do this midpoint first. Somebody tell me what the midpoint of this is right here. 4 and 4. That's embarrassing. I only had one person tell me. Midpoint is what? If you forgot what midpoint formula is, it's the average of the x's. Average of the x's and the average of the y's. All right, so when I ask midpoint again, I want everybody to be able to tell me the next midpoint. All right, everybody has to know that formula. Midpoint, 4, 4. So now what I'm going to do is I'm going to take this, I'm going to go right there. That looks to me like 4, 4. Now, we're going to draw the median. So from the opposite vertex, we're drawing it in here. Does everybody see that? Anybody have any questions with that? So now, guys, come on. I need the slope of this line right here. What's the slope of that line? They can. Oh, it looks to me like you're right. Very good, man. I appreciate that. Slope is 2, right? Slope is 2. Up 2 over 1, up 2 over 1, up 2 over 1, or you can just do 10 minus 4, 7 minus 4, right? Now look, now's the time. If you're not sure about how I'm saying slope is 2, is the time you speak up. All right, this is what I'm talking about. What? That's okay, slope. You have to know slope. This is good review. y2 minus y1 over x2 minus x1. 10 minus 4 over 7 minus 4, 6 over 3, 2. You good now, right? So now, what's the equation of that line? What's the equation of that line? Someone tell me. Y, very good, Bo. Y minus 10 equals times. Everybody should be able to do that. Everybody. All right, point slope form. That's point slope form. Everybody good with that? All right, so now what we're going to do is we're going to draw another midpoint. So I want to find the midpoint between these two. So somebody tell me that real quick. 5, 8. Come on, everybody can do that. If you can't do that, raise your hand and say, come on, help me, please. I'm struggling. I'm drowning. Anybody have any problems with the midpoint being 5, 8? So now I find 5, 8. And looky right here. I'm plotting that point 5, 8. Wow. How nice is that? So what is that equation right there? That's a wimpy one. This is an easy problem now. All right. So you're right. So what is the equation of that line? I know the slope, like you said, is no slope because it's a vertical line. So what's the equation of the green line? No. What's the equation of the green line? It's vertical. X what? X equals 5. Bo said something smart. Good job, Bo. X equals 5. Brilliant. Shh. Now look, everybody have any problems with that being X equals 5? So now right off the bat, we can just say, well, obviously then this point right here is the centroid, right? Everybody see where they intersect is the centroid. Does everybody see that? All right, let me make it a different. So this right here is our centroid. So if we look at that, we could say that's 5 what? Is that correct? 5, 6? So 5, 6 is the centroid. But the reason why I said this was kind of wimpy was because I wanted to actually solve the system of equation. All right, because I have this equation of this line, and I have the equation of this line, and I need to find out where they intersect. So to find out where they intersect, I just plug 5 in for x. And if I plug 5 in for x, what do I get? Y minus 10 equals 2 times negative 2. Y equals what? 6. So the centroid is located at what? 5, 6. Now, hopefully you understand why I said that was kind of wimpy, because they already gave us the x answer. Or they just had to plug it in. Or if you draw a very good graph, you could have figured that out just by using the graph. Is everybody with me on this? Anybody have any questions? What? Good for you. So I want to ask you a question. Do you see where the points where the lines intersect? Yeah. So that answer, the intersection, is the answer. But I want to show you something, because sometimes the intersection might be over here. There's no way to look at that and say where the intersection is, correct? So what we're doing is we're writing the equations of 2 lines and finding where those 2 lines intersect. That's what we're doing. This one was just easy. All right, what?
No, I'm confused why you use 7,
Well, what did you want me to use?
I don't know.
Well, I could have used 7, 10, or 3, 6, right? Shh. Come on now, he's asking me, I'm helping him. Point slope form, right? In order to write the equation, we need a point and a slope. Right? 7, 10 is on the line. 3, 6 is on the line. I could have chosen 7, 10, or 3, 6, so we have the same answer. Right? You remember that? All right. So now, all that work for the centroid, was kind of fun. All right. But now, somebody will be able to say, wow, I can find the centroid even quicker than that. All right. So then once I show you what the centroid formula is, right, everyone goes crazy, right? Because you can find it by finding the intersection, or there's a formula for centroid. So here we go. Say that again. What, did you look that up? That's exactly correct. It's exactly correct. Centroid is x1 plus x2 plus x3 divided by what? 3, comma, y1 plus y2 plus y3 divided by 3. So now everybody take the time, add the x's and divide by 3. Hopefully that is 5. And then add the y's and divide by 3, and hopefully that is a what? Hopefully that's 6. All right, so on the test, you can either graph it or you can use the formula. All right? Yes. No, why don't I need to graph the other line? Because, yeah, they already intersect. And that's why it's called a point of concurrency. All 3 lines will intersect at the same point. So we only need 2. You with me on that? That was a good question. All right, so now I've taught you everything probably you need to know about the centroid. All right, Now, notice here, just because we can, this distance right here is 2, and this distance right here should be what? 4. All right? So there it is. I don't really feel like finding this distance right here, but I can assure you it's twice that distance right there. All right? Yes. No, that's what I'm saying. No, you don't. Once I was so mad, once I figured out this centroid formula, right? All that work, all right? I just like doing that work because it's good review for lines. And some of you forgot everything I taught you about lines. All right, that's why it's a good review. All right, now the next part, we're gonna go back. So that did this one. Now we're gonna have to find the coordinates of the Ortho Center. Now, unfortunately, there is not a formula for the Ortho Center. All right, so we're gonna do that real quick. All right, we are now going to find the Ortho Center. Here we go. And what I'm going to do is I'm going to paste this right here. I'm going to come over here. I'm just going to shrink this down out of the way a little bit. All right. Push this up here. And then let's take a look at what's going on. All right. Now here we definitely need, it looks like positives and negatives. So I'm going to make my X and Y axis. So -3, 3, let's plot that. And you should try to use smaller dots. -1, 7, 1, 2, and then 3, 3. Now, the reason why this one's a little bit easier is because you should be able to tell me, or you should be able to see right away one of the altitudes. All right, so let me address that with you real quick and make sure you're seeing this. All right, from here to here, because this is a horizontal line, the altitude is going to be a what? Vertical line. Is everybody with me on this? All right. So the first line I have is already an altitude. That was an easy one to find. All right. So somebody tell me what that equation is. Thank you so much. X equals -1. And I keep trying to tell you guys, some of you need to start telling me, all right, don't be afraid to be wrong. It's X equals -1. If you didn't know that or you forgot, all right, I need you to remember that. Is everybody okay with vertical line, X equals -1? Anybody have any questions with that? All right, now I'm going to draw another altitude. All right, now altitude has to do with what? Perpendicular. Perpendicular, when you're talking about slopes, perpendiculars are what? Negative reciprocals. That's correct. So what I want to do is I want everybody to take a look at this line right here. And, uh-oh, I don't like that color. We are going to take a look at this right here. And I want you to tell me what the slope of that yellow line is, or whatever. Is it -1? All right, so now let's everybody take a look at that. That slope right there is -1. That slope is -1. So if I want something that's perpendicular, it will have to be what? What? Think for yourself. The slope of the perpendicular would be what? 1, +1. The reciprocal of -1 is 1, right? And then the signs are opposite. So now let me show you now what we need to do. So from the vertex, this is the vertex way over here. I'm counting to the other line, which means I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Now I'm drawing this from here to here. that to me is perpendicular. How do I know that? Because I can look at it and say that's perpendicular, but I can also look at it and say, well, the purple line slope is -1, and the blue line is what? 1, +1. All right, now, just based off of that, if you draw it well, then you can tell me what the ortho center is. What is the ortho center, someone? Is everybody okay with that? -1, 5. All right, so if you do a good job, you will be able to see it on the graph paper. But again, I keep saying, if it doesn't work out exactly, the graph paper is of no value. Thank you very much. How did I get 5? Okay, because look, that's a good question. So this right here now, that's, you see that yellow, right? That is the ortho center, right? So I just literally, here's -1, and then I counted up 1, 2, 3, 4, 5. I just literally counted. All right. But now, again, listen, that's not the scientific way to do that. All right. So what is the scientific way? The scientific way is to calculate the lines. All right. Calculate the lines. So what we're going to do now is we already have this line right here, which we said was x equals -1. Now what I want everybody to do is I'm going to change the color so you can see. I need this line, this green line. All right, now keep in mind, this is -3, 3. And what is the slope of that line? Slope is 1. All right, I want you to pay attention now. What is the equation of that line? Come on, I want someone else besides Drew and Brady. Someone else, tell me the equation. Go. What? AC, tell him. Yes. And then I want a 1 in front just to show you. All right. So that equation, if I write it in y equals mx plus b, is y equals x plus 6. Everybody agree with that? Y equals x plus 6. Now don't just write y equals x plus 6. Tell me if you don't know. Go. You don't know how I got x plus 6, or you don't know how I got that? I distributed a 1, so that just made it x plus 3, and then I added 3. All right, that's perfectly fine. Now you know. All right, now, what did I tell you? We want, the other equation is automatically what? What was the other equation? It tells us, we already knew it was x equals -1. So now I have both equations. I want to find where the equations intersect. So that means I just take this -1 and plug it in for what? X. And what's the y value? And that's the ortho center. That is the ortho center. All right, so I'm agreeing with you. That's kind of annoying. What? Yes, that's what I was saying. All right, because it's not always going to come out perfectly right there. All right, well, it will be for you guys because I don't really, I'm just reviewing the equations of lines. That's what we're doing right now. All right, that's critical right there. All right, and if you knew how to write the equation of lines and you know how to find the point of intersection, then all that's good. All right, now let's go back and see what's next. All right, so that was that. All right, now let's look at the homework because I think I gave you too much homework now. All right, everybody should do 5 through 12. All right, the centroid can be done with the formula. I don't even care. All right, use the formula. All right. Then down here, find the coordinate of the ortho center. Let's get wild and crazy. Let's do 15. All right, you have to do that. And then, of course, I want 16 through 20. Shh. Okay, that's good enough. All right, so you have to be able to tell me if it's an altitude. Altitude is height. Median is midpoint. Perpendicular bisector is bisects the side and is perpendicular. Tell me. What? That's kind of dumb. Yeah, that's probably my own fault. Yeah, so 18 is just silliness. I just can't see it. Then. All right, so 18. I don't care about that. All right, that's your work, guys. All right, that's a good day for today. All right, lots of good things, lots of good information, lots of good reviewing. All right, slopes, lines, intersection. All right, lots of new terms for you. All right, it is important, right, that you get the practice in. All right, do that right now. All right, my homeschool peeps, how are you guys doing on all that? Is that all right? All right, guys. Y'all have a wonderful day, okay? I'll see you tomorrow. Get that taken
Thank
care of. Get that work done.
Thank you. Bye.
Bye-bye, guys.